In this video, we're going to derive the demand for good X. We're going to derive this demand function from the consumer's utility function. Utility equals the square root of X plus the square root of Y, where X and Y represent units of good X and good Y respectively. The consumer has a budget constraint given by this usual formation, where I is consumer income, P subscript X is the price of good X is units of good X, P subscript Y is the price of good Y, and Y is units of good Y. The first thing we're going to do is we're going to get the marginal utility of good X. We're going to take the partial derivative of the utility function with respect to good X, and we get this result. Marginal utility of good X equals 0.5 times X raised to the minus 0.5 power. The marginal utility of good Y, we take the partial derivative of the utility function with respect to good Y. And we end up with this result. Okay, the next thing we're going to do is recognize when a consumer is maximizing utility, the consumer is spending his or her budget in such a manner that the marginal utility of per dollar of good X equals the marginal utility per dollar of good Y. So when the consumer again is maximizing utility, this marginal utility per dollar has to be equal across all goods. So what we're going to do is we're going to substitute in our marginal utility expressions into this optimizing condition. So the marginal utility of good X we said is 0.5 X to the minus 0.5. That's divided by the price of good X. The marginal utility of good Y, divided by the price of good Y. And since we're interested in solving the demand function for good X, we're going to solve this expression for Y. So we want to solve for Y. If you wanted to get the demand for good Y, you would solve this expression for X. So we're going to solve this for Y. First thing we'll notice here is that these 0.5s cancel. And I'll just rewrite this. Like this. And let me go on to a clean slide. So once again, we have something like this. And I don't like negative exponents, so I'm going to just use the rules of exponents to rewrite this. And now we're trying to solve for Y here. So let me multiply through by the square root of Y. And then let me multiply through by the price of good X times the square root of good X. You have that. We want to get rid of this square root of Y. We just want Y, so we need to square both sides. So we're going to square both sides. We'll get that Y equals px divided by py squared, all multiplied by x. We're not done yet. We're almost there. We're now going to take this expression and we're going to plug it into the budget constraint. So we're going to plug this expression into the budget constraint. If you recall, the standard way of writing the budget constraint looks something like this. So wherever we see this y, we're going to plug in this expression now. So that's all going to go into here. So y we're saying is the price of good x divided by the price of good y. That's all squared, then multiplied by x. We're going to solve this for good x, and once we do that, we have the demand function for good x. So I'm just going to clean this up a little bit. So what's happening here, we got py, the price of good y, divided by the price of good y squared. So we're going to lose that guy over there. I'm just going to be left with py, price of good y in the denominator. Let's factor out an x on the right hand side. Next term. Now you're left with that. And all we have to do now is divide through and you have your demand function for good x. The demand for good x equals the consumer's income divided by this mess in the denominator. I hope you found this video helpful.